Hi, my name is Kelsey Rogers. I am here with Oz Hanulu and Yi Kong. We are graduate students on the Nano Hub Education Research Team. We are going to discuss some of our ongoing research. All three of us work together as a team to approach our research questions from a more diverse and innovative perspective. Our collaboration also ensures reliable results. Each one of us will discuss our research project that we led. The research that we will discuss has all been conducted within a required first-year engineering course at Purdue University.
Hi, my name is Oz Hanulu. In this study, we investigated whether a NanoHub-related educational intervention is effective in increasing students' awareness, exposure, and motivation about nanotechnology. For this purpose, we analyzed two educational interventions. In the first intervention, students worked on a mathematical modeling project which was related to nanotechnology. In the second intervention, students were asked to produce an interactive MATLAB-based program to introduce big ideas of nanoscience. NanoHub was introduced in this implementation as a way to learn about nanotechnology. A nanotechnology reflection survey was administered to about 1,200 engineering students before and after these implementations. Results showed that the NanoHub-related implementation significantly helped increasing students' awareness, exposure, and motivation about nanotechnology. Here in these box plots, the changes in each scale after the implementations are shown. When compared to the control group, the experimental group showed significantly larger improvements in each scale. This study also resulted in a coding scheme which in the future can be used to examine effectiveness of NanoHub interventions in changing users' knowledge of nanotechnology. The nanotechnology reflection survey we used in this study is available on NanoHub. You can get it and use it in your educational studies to measure students' awareness, exposure, and motivation about nanotechnology.
Hi, I'm Yi Kong. This study is conducted to develop a nano size and scale instrument to access college students' understanding of size and scale. Size and scale as a fundamental concept of nanotechnology is difficult for students to understand. Few instruments are available to access students' understanding of this concept, making evaluation of nanotechnology instruction at this concept difficult. This instrument was developed based on our previous study that reported college students different levels of understanding of size and scale when they communicate these concepts through a design project. As it shows in this figure, there are 6 different levels of students' understanding. Take a quantitative absolute, for example. Quantitative absolute means objects are evaluated using specific numerical values and scales. This item tests the students' understanding of quantitative absolute. This instrument was then validated by 3 experts in the field of nanotechnology and was then administered to 125 first-year engineering students in a large Midwestern university. Results showed that this instrument is well constructed and none of the items in this instrument need to be modified or animated. This instrument can be used to test the NanoHub users' understanding of size and scale concepts. If you are interested in how this instrument was developed, please go to the website.
Hi, this is Kelsey again. One ongoing initiative of this research team is to characterize what students consider to be simulations and to help scaffold their understanding of and ability to create simulations. In the first-year engineering course, students were assigned a design project that challenged them to create a graphical user interface that teaches their peers about nanotechnology through simulation. Through a grounded theory analysis of 30 teams' design projects, we developed a framework that describes the nature of interactivity, models, and simulations and their solutions. The framework consists of 4 levels. The graphic displayed shows the nature of interactivity, models, and simulation for the 4 levels and how they relate to each other. Based on this model, we created a guided instructional tool to help students better understand models, simulations, and interactivity. The tool prompts students to assess the level of interactivity and the presence of models and/or simulations in the prototypical projects. The tool consists of 3 prototypical pieces of student work that demonstrates 3 different levels. Example A fulfills level 1 and only consists of many buttons the user could click to pull up more text information. Example B fulfilled level 3. It consisted of only a play button that the user could click. The play button would play an animation of a simulation. Example C fulfilled level 4. It consisted of many input boxes that enabled the user to manipulate variables and to see how they affected the model. An analysis of over 300 students' responses to the tool showed that students can assess interactivity fairly well. These results show that the students could fairly easily assess that GUIs with more buttons and more input opportunities are more interactive. The analysis also shows the students lack an understanding of what it means to have a simulation or model present. The response for example A shows a large majority of students thought that simple interactions consisted of a model. The responses for example B and C are fairly appropriate, although the pink area in the pie chart represents an area where there is only a simulation present, which is not possible because all simulations are based on models. These studies are a critical first step to enable the newcomers of this community to develop their own tools to contribute to NanoHub. The model, the analysis of the 30 teams projects, the guided instructional tool, and the analysis of the students' responses to the tool are further discussed in the Understanding Simulation Development group. This group page presents a place for open discussion about simulation development and contains the necessary content to integrate these resources into other curriculum focusing on simulation development. These are a couple of research studies that have been conducted by the NanoHub Education Research Team. We are constantly striving to increase our understanding of how people learn nanotechnology and improve the learning environment on NanoHub. We hope that you find some of these materials on NanoHub useful to integrate into your classroom. Thank you.